I'm making a video on the Amendum channel. It's about physics, maybe. Or I'll get there eventually. Uh, been doing the writing thing. Everybody bitches I should write, and then I write, and dead silence. Dead silence and grotesque mockery is what you get rewarded with. So anyway, it's just curious because this sort of is separate from the Amendum channel, and it's just a physics argument, but apparently it can't be separated. So it's about me. It's not about physics. If somebody else wrote this, I wonder if the response would be the same. I think not. But regardless. I was just thinking about it. I mean, look, from my personal context, I'm saying, okay, yeah, it's too good. I mean, it answers everything. I mean, it answers all the questions you could ask. It explains the force of gravity without bending space. Bending nothing. But it actually accounts for it as a force. Uh, so right there, good, much better. But it does all the rest. It does the time dilation. It does the magnetism thing. It explains photons. It does it all. And I just can't. It hurts my brain to contemplate. Okay, I'm saying if somebody else had written this and I was viewing it, even if it was like warbles on a lot, I'd be impressed. I'd be saying, even if this is wrong, it's an incredible fake. I mean, to come up with an idea that covers all those bases, a scheme, a fake, wow, that's one hell of a good job. Because we're all sticking with the bent space thing, because we all like that, but this is pretty good fakery. I mean, it sure looks like a right answer. I just don't, even if I hate the person, I just don't think I would be able to sit there and say this isn't good science or it isn't good logic. I just don't think I would. And so I'm just wondering about all these characters. It's some people it's like they're fucking gorillas. They're acting like creationists. They're holding up pocket watches and going, "Let's see your evolution make this." Doing preposterously stupid demonstrations. I mean, it's to protect what? To do what besides what? Okay, so yes, mock me. I'm sorry. I mean, if you really think I think there's something wrong here, or you really think your mockery is somehow a persuasive argument, well, it's not. Just amazing. So I wonder, like people like Warbles Arnold or Puro or all these other people, where are they? They should be interested in science. I would be interested if one of these other assholes was writing a unification theory, the thing that's been pursued forever, and it actually explains magnetism, something nobody's ever explained. I mean, I already explained inertia and velocity, but no one cares about that either. Well, I'm just sitting here saying, well, this sort of is a commentary on YouTube. This whole thing happened on YouTube, right? I mean, a little over a year ago, I started this, and after being bugged by the two-slit experiment, because it just didn't fit with my vision of photons. I mean, no matter what I was taught in high school, I just never bought this stupid wave crap. It just doesn't. Waves don't go through empty. You have to have a medium. A wave going through empty space is just nonsense. So I always envisioned photons as things separated by a distance. It's just obvious. I don't care what you make the things out of. You can make them out of marshmallows. It just doesn't matter. But they're things separated by a distance. Anyway, so the whole two-slit nonsense was bugging the fuck out of me, and so I started pursuing this stuff, and the more I started thinking about photons and what forces aren't explained, and then I started thinking about gravity and magnetism, and I'm saying, well, photons, gravity, why not? What happens when a photon doesn't have a frequency? Yeah, what happens? Well, I guess you won't see it, will you? You won't be able to detect it with anything, will you? Maybe you can detect it with a big planet Earth. Maybe that could be a detector, and it'll be pushed into the sun. Yeah, yeah. So I mean, it's just so obvious. So once I did that, then everything else just cascaded out of it, right? So once I had the gravity thing, it started working for the velocity thing, and that did the time dilation thing, and then that did the moved on to magnetism, and it just fits right in. I mean, this is the answer. I mean, people can laugh and mock and do whatever the fuck you want, but this is going to be the truth. And the fact that you were so obnoxious to it sort of says something, doesn't it? I mean, it's like you could have ignored it, or you could have said, gee, nice try, but I don't get it. But the fact that you're so aggressive in your mockery just kind of makes it obvious that, you people are, you atheists aren't any better than the religious kooks. You're in love with your Pope Feynman and your quantum mystery and magic. You want the magic to exist, and this theory obviously just blows up all that crap. I mean, all the woo is gone. The relativity theories are blown up, and the whole concept of the nothing and the extra dimensions and all that shit is gone. Fuck that. It isn't part of reality. There's 3 fucking dimensions, and everything happens in those 3 dimensions. Well, anyway, the subject I'm going to get to is lensing. But I may get, like I said, I haven't looked at the Inmendum comments, but, one of them was some asshole telling me I'm embarrassing myself and blah, 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 and, like my grandfather would be rolling in his grave or something, and I'm just like, it's just such an obnoxious rhetoric. And it's just, and for what? Again, for what is my crime here? Have I cheated in some way? Have I distorted or perverted any facts here? Have I manipulated anything to make this work? No. I've committed no crime, but to say maybe they have it wrong, and your Pope isn't the Pope. Fuck. Well, anyway. So anyway. Yeah, so another, it's just a troll comment, but this is the typical comment, So this guy posts a link to the HubbleSite.org and says, Emendum debunked, and it's gravitational lensing. I can't tell you how pitiful, okay, these images are, but they're pitiful. And what has to be understood is they're such a canard in the sense that none of this works, without them inventing their dark matter and their chicanery. And then they use Einstein's name and say this is Einstein's lensing, and it has nothing to do with anything Einstein said was possible. Nothing at all. So, I mean, just some little facts. Okay, here's a fact for you. On the surface of the sun, the gravity is 70 meters per second, which equals out to about, if you go 70 meters per second, in about 2 months, you'll go the speed of light. So that's the consequence of that speed. And it's only 7 times greater than the Earth's gravitational pull, the pull we're feeling, because the sun is got low density, and density has to do with gravity. Gravity is a density equation. So the gravity on the sun would be a lot stronger if the sun was more densely. It's made out of hydrogen instead of the Earth, which is made out of aluminum mostly, and heavier metals. So the Earth is much denser, so it has a much higher gravity for its size, by size comparison. You could fit many hundreds of Earths inside the sun, and yet the gravity is only 7 times different. But anyway, it's still a significant amount of gravity, and at the location of the Earth, the gravitational acceleration is 0.006 meters per second. 0.006. So just understand how degraded gravity is with distance. And now the other argument is the acceleration argument. So if you took Mercury at its speed and put it where Pluto is, it'll shoot right out of the solar system. To stay in orbit way out there, you got to go really, really slow, and you have to stay in the gravity a long, long time for it to have an effect. So you can't move fast. If you move fast, you're gone. You're leaving town. And that's the problem with this whole idea of lensing. It can usually only happen close to the surface of a very strong gravity if you're theoretically going to bend light. And this theoretical bending of light, like I said, I don't even think Einstein was confident, okay, beyond the fact that he kind of hoped it was true. I mean, he did comment something like, you know, he made some sort of God comment about, I mean, he felt very, you know, happy with himself that it existed, but I'm just saying I don't know what his mathematics are that could possibly justify any of it, because light isn't matter, and there's no evidence that it's affected by really strong gravities like in magnets and stuff. This light isn't bent by any of this stuff. Well, anyway, and the whole idea of bending just is more evidence that Einstein really didn't understand how things move, and they can only move. The little bits do all the moving. See, I've said this before, but gravity is a nuclear force. That's why it doesn't matter what size the thing is, it just matters on its velocity. So I could put a speck of dust in Earth's orbit, and as long as I gave it the same speed as the Earth, it'll stay in orbit. It obeys exactly the same rules. So it's not the littlest, tiniest bits of us are what the gravity is affecting, not us. It's affecting your littlest bits. And they only move in one direction at a time. So there's no bending anyway. Let's say if I was going to bend light. Okay, so light's going in a straight line. If you were to bend light by applying some force, right? So you apply some force, gravity, and you're going to bend the light. Well, light does this straight line thing. And so all you can really do is knock the light in this direction. But it's still going to go this way. So you can knock it in this direction, but it's still going to go this way. Its angle is not going to change. So there's a big difference between still going this way and having your angle changed. And gravity will not change its angle. It creates acceleration in one direction. So when the Earth travels around the Sun, it doesn't really travel an arc. Parts of the Earth go this way, and then parts of the Earth go this way. And then they switch roles. Then the parts that were going this way go this way, and the parts that go in this way go this way. And they sort of take turns, so it all adds up to a circle. But the pieces inside you can only travel in one dimension at a time. That's how light works. It can only travel in one dimension at a time. It can't travel in two dimensions at a time. It's one of those little... If you really understand it, you'll understand that's how the truth is. So anyway, the point is that you couldn't really, if there was a gravitational lens, all it could do is move light over a little bit, but it couldn't bend its angle. So it would still end up looking like it's coming from the same place. It's just coming from a tiny, tiny, tiny different same place. I mean, it would just be an irrelevant difference, a meaningless difference. So it wouldn't provide any lensing, so to speak. But I don't even know if I want to, I mean, I don't need to get to this argument to make the argument that gravitational lensing is supposed to only be possible in very, very, very high gravity. And what you have to understand is high gravity means high velocities. If you're in high gravity, you've got to move really fast to not crash into the planet. And if you don't move really fast, you're going to accelerate really fast into the gravity, right? So again, in the strongest gravity of the sun, if you could maintain that gravity for any amount of time, it would only take 2 months for you to be going the speed of light. So that's sort of a context for looking at some of these silly images. So let's look at some of the silly images and understand. I guess another thing to understand is if there's a circular, like say you have some little scattering things like this, okay, and it almost looks like a circle. well, the idea would be if that was to be true, then you'd have to understand that the gravity is that entire circle, and that through that entire circle you have intensely strong gravity. You know, speed of light in 2 months kind of gravity. And if you have it way out here, you know, millions of miles from what its center would be, millions of miles, obviously everything would start moving the speed of light because it's millions of miles to that center, and you can't assume that everything has enough velocity not to be falling into something. And as you'll see in these images, there's no evidence that anything's doing any orbiting. There's no look of these clusters as if there's any orbiting taking place whatsoever. So this stuff would be falling into the gravitational center at speeds that would have it moving the speed of light in 2 months. 2 months. Is that realistic? I mean, this is terrible physics. I'm sorry. I mean, I'm sorry to say it, but I mean, physicists are just so full of fucking shit. I mean, cosmologists. I mean, they ought to call them cosmologists because, yeah, they might as well be doing makeup because they don't understand physics. So here's one of these gravitation. This is one of the famous ones. I mean, you know, half the images they use are just cutouts. Like they'll just cut out this piece and say, see, gravitational lensing. See it? Ooh. So these are like overlapping ones. Okay, so I won't even go into just explaining how you'd never have an overlapping lensing. This one I like because it's a dead straight line. I mean, it's a dead straight line. There's no way to explain a dead straight line. So the idea here is that you have some sense of a pattern, you know, some sense of a shape here. Now I'm going to argue that this whole thing is some sort of artifact that's way in front of this. Like this is 5 billion light years away, this cluster. And this might be a billion light years away, this stuff. And what it is the remnants of like a supernova or something. And that's what this stuff is. So it has nothing to do with lensing. This is some other remnant, okay, that's been just drifting on its way. So anyway, so yeah, and you have these weird shapes like this. So here's another one, a big angly bend in it. No, there's no way to explain that. Because again, you got to remember, this is intense gravity here. So they're saying that the gravity here is like, say, whatever, 100 meters per second per second. 100 meters per second per second. These galaxies would be hurling through to this center at, like I said, at light speed in 2 months. Is there any evidence of that happening? They're clearly not orbiting. I mean, you clearly don't get any indication that these things are all spinning around here at high velocities to maintain where they are standing, right? So you have this incredibly strong gravity, and yet you have absolutely no evidence of any center of the gravity, no evidence of the center of the lens. This is like I mean, again, you could give these problems to grammar school students, and they could probably say, well, find what's wrong with this notion. Here's the facts of gravitational lensing. Lenses have to be round because strong gravity will always go round. Okay, no material object has ever been found that has like a mass greater than, say, the moon that isn't round. You know, spherical, generally speaking. Because that's what gravity does. It creates surface pressure that pushes everything, liquefies everything else, and will force something into a round shape, inevitably. Anything material. Now, most galaxies even tend to go round, and they're very loosely configured. As you can see, this one looks like an S. But I mean, they're a loose configuration of these spots. You know, so they're not even really dense. They have very little density as matter. And clearly, the outskirts of a galaxy will have very low gravity. You'd have to be moving really slow to stay in there, because there's so little density to the mass. Yes, there is a lot of mass total, but these things are huge. And so the mass is so spread out that it's even weaker than, say, the hydrogen sun, or it's an incredibly weak gravity because the density is so thin when you add in the empty space. So that's why they invented dark matter. So they want to say that, well, most of the mass is this special matter that doesn't reflect light and is transparent to light. So the light goes right through it. Well, then we should see these objects that are getting lensed. If the lens is invisible, if it's made out of matter that's invisible, then we should be able to go right through it and see the thing that's actually being lensed. Nothing should be obstructing it, technically. So, yeah, so there's a real problem with this stuff. And again, this stuff being lensed, this brightness here you see, these objects are supposed to be, say this cluster is 5 billion light years away. This stuff being lensed is supposed to be 10 billion light years away. Now look how bright some of these lines are. How is the light that's even 5 billion more light years away, as you know, this bright? I'd say that doesn't make much sense either. But again, the straight line, dead, no way. This isn't a circle, so you know what I'm saying. So they're basically, the argument is that somehow we have this intense gravitational field that's all kind of loopy-doopy, kind of sort of glumpy round. It's not spherical. Now it's kind of, well, it goes a little bit this way, and it's a little wider over here, it's a little thinner over here, and it's got a bigger arc here and a smaller arc there. Not possible. So anyway, and so they call this, they'll even use the word Einstein, that this has something to do with what Einstein theorized, and Einstein would never have said this was possible. He was talking about lensing right on the surface of highly dense objects, not densities spread out like this. And again, for this to work, they have to put in tons and tons, 80 times as much matter that's in here of dark matter, this special matter that's invisible but yet creates gravity. And yet there's no evidence that it exists in our solar system at all. But it exists here, and in uneven amounts. There's a big pile of it here, and there's a little pile of it over here, and there's a little pile of it over here, and it just conveniently sort of piles up in vague circles. Yeah. This is good enough for you people? This is in Mendham debunked by this. I mean, seriously, by this. Alright, so we'll move on. Here's another one. Alright, so this one kind of has a little bit, these are supposed to be the lensed objects here, I suppose. And these are supposed to be the same galaxy, I would imagine, being lensed by this single location. So at least it's a little more logical. This almost does look like a circle here. So that's good. I mean, so you do get some sense of there could be a lens here. But again, look at the masses here. Does there look like there's anything here that's doing any kind of swirling or anything like that? Again, understand that the gravity here has to be, 100 meters per second per second. This stuff would achieve light speed if it doesn't have a velocity, in a matter of 2 months. So, why doesn't this thing have the shape of a galaxy? Why isn't it doing this swirly thing like the galaxies are doing? Why is there no evidence of the galaxy swirl if there's that intense a gravity there? So intense that it's creating lensing way out here. Now, again, this does sort of look like these are two similar things. I mean, it has a spot here and a spot here, but they are different colors, as you see. So one appears to be going away, and one appears not to be moving away, so that's a little bit suspicious. And they don't really have the same shape. And look, they're looking at millions, billions of stars with their telescope. Yeah, sometimes you're going to see something like the face on Mars. What if they end up seeing a face like Mars out in space? Is that what they're going to say? There's God. We saw God's picture because it's in space. A galaxy looks like God. Looks just like Charlton Heston. So therefore there's a God. I mean, it smells a little bit like that. So anyway, and there are, this is curious here. See, this circle again doesn't line up. The arc of this circle is bigger. See these little lines coming off of here? Now I don't know whether they're saying that's some sort of lensing, but it really can't be, because I mean, they're saying if these three objects are all the same object behind this object, they're incredibly bright, which is the first problem. And again, the images are overlapping, which is a sin against lensing. And again, this arc, which isn't even really an arc, is much narrower than this arc. So that doesn't make any sense either. But I mean, this is not optically correct. This can't be called lensing because it isn't obeying the rules. But like I said, if you were to just take these two and you could say there was a lens here, I would argue that it has nothing to do with this location. It has to be in front of it. Maybe it's a black hole or something. But it's not associated with this star, because number one, it's not centered on this star, quite obviously, and number two, there's no evidence of any orbits, and so all this stuff would be flying into that gravity. You would see just as you see all this mist around galaxies, if galaxies were being hurled at high speed into some kind of gravity well, you would see the stuff lag behind. So anyway, so I mean, but this is in Bendham debunked. I mean, look at this great image. I mean, that just, wow, it's undeniable. I mean, look, it's so perfectly round. It looks exactly like a lens. I don't know whether this little thing over here is supposed to be a lensed object. Is that it? Yes. What here is supposed to really impress me? Oh, that's right. It's a nothing image. Yeah, that's right. There's nothing here to impress anyone. So this is just, again, they just cut out the image from another image and they said, wow, look at that. And again, on its face, you can just look at it and you say, well, this object couldn't be causing the lensing because the lensing is not spherical. It's not consistent with a proper circle, and it has to be a proper circle for it to have the gravity necessary. Now here's another example. It's dead straight line. What's that? This thing is, who the hell knows what this thing is? It's like a giant slug. It can't possibly be lensing. It's so freaking wide. To be able to lens the image that perfectly, that wide, means that we'd have to have the same gravity throughout that whole distance. You have to bend the light exactly the same amount for maybe that's 1,000,000 miles right there. How is that theoretically possible, to have exactly the same gravity for 1,000,000 miles? What's this? What's this supposed to be? Let's look, a straight line, this, whatever that is. And then you got dashy, more thick stuff again. This doesn't happen with lensing. Emendum debunked? No. Cosmology debunked. I mean, this lensing thing is a pile of shit. It doesn't happen. I'm just telling you, it really doesn't. There's no such thing. You can't bend light. You just can't. It just does this sideways thing. You can, sideways up, sideways. You can't bend light. You can only diffract it. You have to have it go into an electron and be shot out at a new vector. It has to go into an orbit and then be shot out in a new direction. Just like a spacecraft goes in, gets caught in the orbit, and then shoots out anywhere it wants to. That's the only way you can change the direction of light. Electrons. Quantum electrodynamics. But anyway, what is this? This is not you can't lens this way. It's double lines, overlapping images. You can't do that. There's no theory that makes this possible. And especially in, again, the context that somehow this cluster is causing the gravity. There's not even close to anything close to enough mass in that cluster to create powerful lensing like this. And again, look how bright this object is. So this object has to be billions of light years behind this cluster, and yet it's this bright. It's blue shifted, which, who knows what that means. And look at this angle. I mean, it's not even, that's not even close, to an arc. So the gravity has got a flat side. There's a flat side to the gravity. I mean, really, can you make any sense out of that? Oh, I'm evil. Well, I mean, how dare I? Look at this one. This one's got rain coming down off of this galaxy here. Then it's got little straight lines flying here. And then a little UFO guy. I saw a little, they have a cutout of little UFO guy. But there you go, right? It's like the Martian thing, right? Oh, it's a UFO. Look, it's looking right at you. It's looking right at you. Well, that proves it, right? I mean, look, I'm totally debunked. I mean, this is obviously, there's no straight lines. I mean, you couldn't find a lens here. You could spend the rest of you could spend forever looking at this image, and you're not going to find anything that looks anywhere close to a round lens anywhere. I mean, it's a silly image to call gravitational lensing. I mean, these are time exposures. Who knows how long they have to sit there and look at one spot, to get these exposures. So something 2 billion light years away could be doing something. There could be just old fragments from an explosion, a supernova, who knows what, and that stuff moves across, and forever, whatever. There's some sort of star closer that's able to reflect light off of it, and that's what you're seeing. I don't know what the fuck that is. That really is quite bizarre. I mean, it's just dripping, into space. It's got a leaky pipe. So here we go. Yeah, what is this? Okay, so we got the swirly galaxy here, and so you got a perfect image of the swirly galaxy, and then somehow you lensed a lumpy trail that goes around a little sun there. The lumpy's off this way. I mean, this is obviously not lensing. This is obviously being caused by, this thing here being torn apart by the influences of these gravities that passed by. I mean, you could argue that it started in this trajectory, and it was being pulled by these competing gravitational sources. And it tended to go up this way because this gravity's stronger, and then especially when it got here, it had all kinds of trouble and interacted and got broken off. But it's something like that, obviously. Look, I mean, this lensing, and then you got a straight line coming down here, and then you got almost a straight line over here, and you got a little line over here. I mean, lenses won't do that. Whatever you want to call these, galactic lenses will not behave this way. There's no theory, there's no math, there's no anything can make that rational as a lens. It's not a real thing as they're describing it. So here again, I'll just make, this is the close-up of the other. See, they're just using a bunch of the same images, pulling out the close-ups and just calling them new images. Same image before, as I pointed out. Look at the unevenness between the sizes of the lens. Just, no sale. This arc, very different than this arc. You can't do that. I don't know which one this is, but it's so pixelated that I don't see any value in this one either. Again, nothing spherical. I mean, like I said, these should be very precise. Very, they actually should have a sharp, spherical representation to them, even if they're on a crooked angle. Well, on a crooked angle, you're not going to see this back side, so that's not even possible. You can't see more than one side unless it's facing you. I mean, look at this one, for fuck's sake. I mean, all kinds of lines. Just lines. Line, 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 line. So they're saying this whole, through this whole area is gravity that would make something move the speed of light in 2 months. And yet, is there any evidence of any of this stuff with having any velocity counter to what the gravitational center is? The implied gravitational center of this lensing is here. Is there any indication that anything has a velocity that's maintaining its orbit around that strong gravitational center? Obviously not. So I don't even know what this one was supposed to be, but these are nice galaxies anyway. But yeah, straight line, different angles all over the place. I just don't see any use in saying that's lensing. It's obviously not lensing. And that's it. Hey, it's me. Hey, with my poopy. Hey, oh, poopy. Yeah, me as a, whatever, 13-year-old? I don't know, somewhere in there. Pathetic. Anyway, so, that's enough. Till next time, I guess. Yeah, so I'm just lamenting. I'm just disappointed in people. Disappointed in the internet. See, I mean, YouTube could have, shown itself like, wow, look what we did. Somebody, had an idea and spent years working on it, and, we encouraged them and built it and we made it happen. And no, all you assholes have done is try to discourage me from the very beginning. And in spite of the impediments you presented, I have endeavored to persevere, and we'll say fuck you at the appropriate moment. Yeah. So yeah. Even Piro, his comments, he's changed his tone a little bit, but his comments used to be, you're embarrassing yourself and blah blah blah, the same old kind of bullshit. Oh, don't dare, think outside the box I tell you to think in. We'll see who's embarrassed, fuckers. Yep. So anyway, link below to the paper. Like I said, it's getting there. It's do a little additions here and there, but it's mostly the stories there. I mean, the inertia paper, I don't want to put the inertia stuff in this document, but, I don't know if I need to. That's how I really feel about it. I mean, they are sort of different subjects, so I think I can wrap this up in a nice conclusion that ties it all together and just kind of explains that it really is amazing, that it's all about polarization and frequency. Frequency is what gives photons their magic. Polarization is what gives magnets their power. And a combination of the two enable matter to form into fairly complex orbits that are durable. And, some idiots on the internet want me to diagram the entire abiogenesis of orbitals. And I really don't think I need to do that. I mean, everybody sort of agrees that hydrogen was the first atom and that the rest of them are built out of that model. And, really, it's just, obviously, to survive, an orbit has to be able to move. It has to have enough density to it that it doesn't lose its structure by moving. The moving part's kind of complicated for matter. And that's sort of what I pointed out in the inertia document, is that matter doesn't like moving. Moving weakens matter. I mean, the more velocity you have, the more likely are you to fall apart. And ironically, it's, I said this in one of the draft science videos, but I mean, this is the kind of thinking that's just so, they just don't get it, that this is so interesting, is that, we think of velocity, and we think of how when something's going really, really fast, like a bullet or something, that, and it hits something soft, but it still falls apart and is ripped apart by the forces. We just don't get the idea that what's really happening is the bullet has gotten very weak by traveling very fast. That velocity weakens material structure. And that's why a grain of dust, if you're a satellite, could blow you up. It's because your matter is really vulnerable. Because the faster you go, the more time your matter's spending not doing its orbit thing, and instead doing the moving thing. So it's like this this staggered line. Oh, where's that drawing? I guess the orbit line is over here now, but it's like this orbit thing, where if you're going two directions, it means you have to not go this way for a little while and go this way, and that degrades the matter. The matter can't. So for an orbit to move, it has to be a rather substantial amount of stuff orbiting, so it can afford to lose a little bit of its structure as it moves. And that's just one of the, like I said, it's not a fact you could ridicule. It's a fact that verifies the theory. Ironically, but the creationists wouldn't understand that. I mean, they don't understand that the fact that human beings make watches kind of is something where you'd say yes because it has utility to a human being, but nature would make one if it ate. So if your watch actually had to eat to survive, then nature could make one. Evolution would make one. But the fact is, you feed your watch, you wind it, you take care of it. If it had to take care of itself, nature could make it. Anyway. Oh, yeah, I guess that's it. So anyway, quite discouraged. I'm just pathetically disappointed in people. But somebody, I understand why the people who are, they don't understand physics. I understand why they're staying away, and I don't want people to just do this fakey, good job kind of crap. That's just bullshit if you don't know what I'm talking about. But I just mean there's got to be some people on YouTube that know something about physics, and they really should be able to tell that this is goddamn interesting. That this actually works. This does explain it. It fucking works. Anyway. Enough said. And such. So, yeah, I'm just discouraged. So I'll just sit here and be discouraged for a little while. So anyway, I was thinking I gotta make a documentary, really, funny documentary, but yeah, physics, fun physics, and just explain how it was so obvious all the time. All these smart people couldn't figure it out. Anyway, that's the way it happens. Yeah. Anyway, okay, that's it. Till next time. Link below if you haven't read it. Till next time.